Okay, so we're looking at homework number 3, problem 1. The electric field strength is 50,000 newtons per coulomb inside a parallel plate capacitor with a 2.0 millimeter spacing. A proton is released from rest at the positive plate. What is the proton speed when it reaches a negative plate? Okay, well, the first thing to do would be to figure out our knowns, which is the strength of our electric field is given to us as 50,000 newtons per coulomb, and the distance between the plates, which I converted from 2 millimeters to 2.0 times 10 to the negative 3 meters. And then we also have to find our speed, which we know has to do something with how much energy is involved. In this case, we're going to start with electric potential energy and then convert that into kinetic energy, because no energy is lost, it's just transferred. So we're going from how much energy we have to work with into how fast we're actually moving. So now just taking this equation for electric potential energy, which is charge times the strength of our field times the distance, we get something looking like this, where we have the charge of a proton plus 1.6 times 10 to the negative 19th coulombs and our other two values from before. And that should give us about 1.6 times 10 to the negative 17th joules. And again, we said earlier, the electric potential energy is equal to kinetic energy. And kinetic energy we know is equal to 1/2 times mass times the velocity squared. So now filling in our values, again, kinetic energy equal to our electric potential energy, so we just move that value down. We have our mass of our proton, which is in kilograms, and we're just solving for velocity here. So doing some rearrangement, multiplying this by 2, dividing it all by the mass, and then taking the square root, which should look something like this. We then get a velocity for our proton of 138,426 meters per second. Or another way to write that would just be 1.4 times 10 to the 5th meters per second. And that's how we would find the speed of our proton.